On combining like terms. Your goal for today is I can simplify, and this is going to be the key word here, algebraic expressions by combining like terms. Now, you probably haven't ever heard of combining like terms, but you do know what like terms are. We looked at them a little bit in the last few lessons when we were doing the distributive property and other properties. So that's going to come into play with this as well. Before we actually get started with combining like terms, we're going to play a little game here. And so it's the property game, just to review. So select the correct property demonstrated by 3 times 4 equals 4 times 3. So think about it. Which one would that be? Identity, distributive, communicative, or associative? If you said communicative, you are correct. All right, let's try another one. Which property is demonstrated here? 3 parentheses 4 plus 5 close parentheses equals 12 plus 15. Is it identity, distributive, associative, commutative? Let's think. If you said distributive, you are right. Excellent. Okay, how about this one? Which property is demonstrated here? 4 times, open parentheses, 3 times 5, close parentheses, equals 4 times 3, close parentheses, times 5. So they're in the same order, but the parentheses are in different places. Associative. Nice job. Nice job. Okay, what about this one? 5 times 1 equals 5. Which one is it? Identity. Identity. Okay, excellent. So we are a master. Perfect. So we're going to go ahead and get started with combining like terms. And we need to go ahead and get started with a definition and some examples. So like terms, and this is very important, are terms whose variables, remember those are letters, and exponents are the same. Okay? The coefficients, they can be different. So let's look at some examples of that. So, an example of terms that are alike or like terms would be 2x plus 3x. The variable is the same. They're both x's. The exponent is the same. There's no exponent there. But the coefficients are different, 2 and 3. And that's okay. So we can combine those. And combine means to put together. Okay, let's take a look at another example of like terms. 4w to the 9th power plus 6w to the 9th power. These are also like terms. It does not matter that the coefficients are different. That's okay. What matters very greatly is that the variable is the same and the exponent is the same. Now, if one of these was w to the 9th power and one was w to the 8th power, we could not combine them. They would not be like. So let's look at some examples of unlike terms. So some non-examples. So 2y plus 3x. Well, very simple. The variables are different. We cannot go any further. We have to stop there. Okay, another non-example would be 10x to the 4th power minus 14x to the 3rd power. Yes, the x's are the same, but the exponents have to be the same too. And in this case, one exponent is a 4 and one exponent is a 3, so we cannot combine them. All right, well, let's get started by working through some real examples. Okay, so here we go. We have 4x, negative 10x. Are they like or unlike? Well, check your two things. Do they have the same variable? X. Yes. Do they have the same exponent? No exponent, no exponent. Then they are like terms. Let's try this one. 6p, 5p to the 4th power. Check your two rules. Do they have the same variable? Yes. Do they have the same exponent? This one doesn't have one. This one is p to the fourth. So these are unlike terms. Okay, negative 12y to the third power, negative 12x to the third power. Do they have the same variable? No. So you stop right there. They are unlike terms. Okay, let's try one more. 15x squared, 17x squared. They have the same variable, x, and the x has a second power here, and it's the second power here, so they are like terms. Okay, let's try this one here. Okay, so you'll remember we did this in a previous lesson. This is where we're going to tear apart the coefficients, the variables, the terms, the constants, and all that stuff. But I'm adding one more category to this, which is we're going to put the like terms together. So let's go ahead, and I actually want to work backwards. So I want to work from the bottom and go up. So first let's find our constants. So is there a number by itself? 6x, negative 2y, x, negative 5. So there is a negative 5 that is by itself, and that is the constant. Do we have any coefficients? Those are the numbers in front of the letters. So we have a 6 here. We have a 2 here, but what's the sign in front of it? Minus, so it's a negative 2. And there's an invisible number right here, and if you remember, that invisible number is 1. Okay, do we have any variables? Yes, we do. We have an x, and we have a y. And again, this should be reviewed so far. And then I'm going to jump up here. I'm going to skip like terms for a minute. I'm going to go to terms. What are our terms? Okay, so those are the different units of the expression. So I have 6x, I have negative 2y, I have x, and my last one is negative 5. Okay, so that should be all review. Now what we're going to do is we're going to see which terms are like each other. So the first thing that I do, and you can use some colored pencils to do this, you could use highlighters, you could use shapes, whatever you want to do, is I like to put a box around the first term, 6x. Is anybody like 6x? Same variable, same exponent. Well, here's a y, so that doesn't count. Here's an x, same exponent, because there is none. Okay, so he can combine with this guy right here. So I have 6x, and I take the sign in front of the second term plus x. Okay, now let's see, do I have any other like terms? Okay, so I have a minus 2y here, and I have a 5 over a negative 5 over here, but he doesn't have a y, so he can't combine with anybody. Okay, and then I have a negative 5, and there's no other number that matches with a 5 because they all have variables. So my like terms here are 6x plus x. Now, how do you combine those? Well, what you do is ignore the variable and the exponent. Add the coefficients together. What is 6 plus? Remember, there's an invisible 1 here. So 6 plus 1 is 7. Now, take the variable and put it back. So your answer is 7x. Let's try another example. Okay. So again, I'm going to work backwards. What are my constants, the numbers that are by themselves? I have a 4, and I have a 10. Again, this should be review. What are my coefficients? That's the number in front of the variable. I have a 13. I have a 6, but the sign in front of it is minus, so it's a negative 6. And I don't have any other ones. What are my variables? Well, this time I only have one variable. It's m. And now I'm going to skip the like terms. What are my terms? The different units of the expression. So I have 13m. I have 4. Remember, the minus goes with the number next to it, so I have a negative 6m, and I have a 10. Now, what are my like terms? Always start with the first one, and again, you can highlight it in yellow, you can use colored pencils, whatever you want to do. I like to draw shapes. So I have a 13m and no exponent. So what other term in the expression can he combine with? He can't combine with the 4 because he doesn't have an m. Here's an m, and he has the same exponent. So remember, always take the sign in front of it, so they are like. And this 10 does not have an m, so they cannot combine. So my like terms are 13m, and this time the sign is minus 6m. Now, same process as last time. Ignore the variables for a minute. What is 13 minus 6? You should get 7, and then put the variable back in, m. Now, like terms do not always have to have a variable. So in this case, I also have a positive 4, and then I have a plus 10 over here. And they are like terms because they have no variable. They are just whole numbers, and they can combine as well. So my other like terms are 4, and I'm going to take the sign in front of the number, plus 10, and that is 14. Okay, let's try another example. All right, so now that we've broken them apart, let's actually start to sit here and combine them. So we have 3y plus 4y. Ignore the variables and just add the coefficients. That's the number in the front. 3 plus 4 is 7, and then put the variable back in, y. Now, if that y had an exponent with it, you would put the exponent back with the y as well. So your answer for this one would be 7y. Let's look at this guy. Again, ignore the variable. 14 and 8. What's 14 minus 8? Well, it's 6. And now put the m back with the 6. So your final answer is 6m. Okay? Let's get a little bit more complicated. So here, and we always want to check that they're like terms. I have a k with no exponent, a k with no exponent, and a k with no exponent. So ignore the k's for a minute. I have a 7. What's my invisible number here? A 1. And I have a 2. So 7 minus, because there's the minus, 1 plus 2. What is 7 minus 1? 6. What is 6 plus 2? 8. Don't forget to put your variable back in. 8k. All right, let's try this one here. Check to make sure they're like terms. A with no exponent, A with no exponent, A with no exponent, A with no exponent. So, what do I have? I have 14 minus 6 plus 2 plus 11. 14 minus 6 plus 2 plus 11. Well, 14 minus 6 is 8. 8 plus 2 is 10. 10 plus 11 is 21. And my variable was A. Okay, let's get a little bit more complicated here. Now, you're going to see I have an h with no exponent, an h with no exponent, a g with no exponent, and another g with no exponent. So I have two different variables, and I need to take them one at a time. So, again, I like to use shapes. So I have a 4h plus a 6h. And then I have a 12g minus 2g. Okay, so I'm going to work with my h's first. Ignore the h for a minute. What is 4 plus 6? 10. Now put the h back in. Now I'm going to work on my g's. What is 12 minus 2? 10. And then I put my g back in. Now, What is your operation in the middle? Well, when I do 12 minus 2, that is a positive 10. So I put plus 10. If it ended up being a negative 10, you would write minus 10. So this right here is your final answer, 10h plus 10g. And you cannot go any further because h and g are different and they cannot combine together. Let's try another one. I have a k with no exponent, an a with no exponent, a k with no exponent, and an a with no exponent. So I'm going to first figure out what my like terms are. I took care of my k's. Now I have my a's. Okay, 5k, and here's a minus sign, k. So I'm even going to write it like this, 5k minus k. What's the invisible number right here? 1. What's 5 minus 1? 4. Add the k back in there. Okay, now let me take care of my a's. 20a, here's a minus again, minus 6a. What is 20 minus 6? It is positive 14. And then I put my a back in there. And this right here is my final answer. I cannot go any further because k cannot combine with a. Okay, we're going to take it up another step. We have some exponents here. So I have a d to the third power and a d to the third power. They can combine. I'm going to ignore the variable for a minute. What is 5 plus 5? 10. Now put my d to the third power back in there. And 10d to the third power is my final answer. Okay, over here I have an x to the second power, an m, and an x to the second power. So I'm going to figure out what my like terms are. And again, you could highlight them different colors. You can use different shapes around them. Whatever works for you. Okay, so let me work with the x squared first. So I have 8x to the second power, and then that's a minus 3x to the second power. So the variables and the exponents are the same, so I'm going to ignore them. What is 8 minus 3? 5x to the second power. Now I got to go back to my m's. I just have one, positive 9m, so plus 9m. And this right here is my final answer. I cannot go any further because I cannot combine the m with the x. It cannot work. Okay, here I have r with no exponent, r to the fourth power, and r with no exponent. So this guy right here can only combine with this guy right here. He cannot go with this r because he has an exponent of 4 and he does not have an exponent. They need to match with the variable and with the exponent. And so the 2r to the fourth power is all by himself. Okay, so I have 9r and then I have minus 7r. Well, they're the same variable, so 9 minus 7 is 2, and then I keep my r. Then I have positive 2r to the fourth power, and he's by himself, so I just add him on. Okay, now I have this guy over here. I have n with no exponent, n with no exponent. I have a whole number 5 and another n with no exponent. So I'm going to put my like terms together. And remember, you always take the sign in front of the number. Okay, so I have 3 n's here. So I have 3n minus 2n minus n. Well, what's that invisible number here? 1. 3 minus 2 is 1n minus 1n. 1 minus 1 is 0. So they cancel out and they go bye-bye. So all I'm left with as my answer is this 5 right here. And that is my answer because he cannot combine with anybody and all of the ends subtracted themselves out. Okay, we have some more examples here. We have a 12 whole number. We have a p to the third power. We have a 1 as a whole number. And we have a p to the third power here. So I'm going to identify my like terms. My 12 is a whole number. I have a -1 here. I have a 13 p to the third power here, and I have a -9 p to the third power here. So let me start with my first one. So I have 12 and then -1, and that's going to be 11. And then in blue, I have my 13p to the third power, and that's a -9p to the third power. And because they're like terms, I can ignore the variables and just deal with the numbers. What is 13 minus 9? Well, it is +4p to the third power. And so my answer is 11 plus 4p to the third power. Okay, let's try this one here. I have m with no exponent, whole number 3, m with no exponent, and a whole number 3. So here I'm going to start to find my like terms. And again, use markers, color pencils, highlighters, shapes, squiggly lines, whatever you need to do, but you need to separate your like terms. Okay, so here I have m, and then here I have plus 9m. What's the invisible number here? 1. What is 1 plus 9? 10m. Okay, now I have to deal with my whole numbers. I have a 3, and then I have a -3. Well, 3 minus 3 is 0. It's nothing, so we don't have to worry about it. So my final answer is 10m. Okay, we have this guy down here. We have r to the 5th power, a whole number 10, r to the 5th power, and a whole number 7. So I'm going to go ahead and start to separate my like terms. Okay, so here I have 2r to the 5th power plus 2r to the 5th power. Now because they're like terms, they're both r to the 5th power, I ignore that and just add the coefficients. What's 2 plus 2? 4. Now I'm going to add in r to the 5th power. Then I have my whole numbers. So here I have 10, and then I have -7. Well, 10 minus 7 is +3. So my answer is 4r to the 5th power plus 3. They cannot combine. Do not do 7r to the 5th power. They do not have the same variable or the same exponent. So it's very important that you do not take it a step further. All right, that is the end of this video and the introduction to combining like terms. We're going to do some more work with combining like terms in the next lesson, but it's important to practice before we do that because we're going to start to add in some shapes.